up a notes page to be able to work with a question on transition matrices. Now, the transition matrix size that I'm going to use in this particular notes page is a 3 by 3. You may need to have notes pages set up for situations where you've got 4 by 4. It might be simpler for you to have that sort of thing set up. So I'm going to set one up with a 3 by 3 and just show you, once one is set up, how easy it is to perform the required calculations. So I've opened up a new document, and what I'm going to do is I'm going to add a notes page. So I'm going to press number 6. Now the notes page, or the notes application, is the least well known, but probably the most powerful of all the applications, particularly for exams. And you can, in a notes page, you can add text. So for example, I can type in transition matrices, if I can spell right, matrices, and then something like 3 by 3 case, and then press enter. So it just shows you that you can type in some text. Now the key to setting up these notes pages is this object called a math box. And a math box in a notes page is where you can perform calculations, and if you set up your math boxes nicely, they can be linked. Now what we're about to do is, you wouldn't do this in the exam, you would do this in the lead up to the exam. Okay, you do this in the lead up to the exam. So we're going to set up a situation where if you get a question in the exam and it's a transition matrix, and the transition matrix is a 3 by 3 transition matrix, then you can use such a page to answer questions about numbers in subsequent states after a certain number of transitions. So the first thing I'm going to do is I'm going to show you how to add or introduce a math box to a notes page. So what you can do is, if you press menu, then number 3 for insert, and what you'll see there is number 1 is math box. There's also a shortcut in brackets there. Control M is a shortcut on how to, or being able to, insert a math box. So if we press 1 for enter, I can tell that I've introduced a math box. I've got a box, and then outside that box I've got a red border, a red dotted border, and that illustrates or indicates to me that I have got a math box. If I press the big button to the right, I'm outside the math box. Big button to the left, I'm inside. Big button to the left again, I'm outside. Big button to the right, I'm back inside again. When you're making a notes page and using math boxes for the first time, just be very aware of where you are, okay? So in this instance, we're inside a math box. So what we're going to do is we're going to assign T to be a 3 by 3 transition matrix. So first of all, I'm going to type T. Then, now assign is a command. It's denoted by colon equals, and it works the same as define, works the same as store. I happen to like using assign. If you do also start using assign, remember that it's colon equals, it's not equals, right? It's colon equals. To access it from the keypad, and this is another reason why I like it, you press Control and then the symbols template. Okay, so we've got T, and we're going to assign it to be a 3 by 3 matrix. So if we press the catalog button now, what we'll do is if we go along to our M by N matrix template, the nice thing here is that the symbol illustrates that when the dialog box comes up, when you press enter, we will automatically have a number of rows being 3 and the number of columns being 3, which is exactly what we want. So with that in mind, I'm happy with that, so I press enter, and here our 3 by 3 matrix template. And what we need to do now is we need to add the elements. So the way that this operates is that we want our columns to sum to 1. Right? We want the probabilities to sum to 1. And there's deep reasons for that. It's to do with you take the transition matrix and then multiply it by the state matrix. And that's the reason why we have the columns adding to 1. So here, and I'm going to actually add these elements column by column, and we just need to check that they do sum to 1. So we've got 0.85, 0.06, 0.09, then go up to the top of column 2, 0.09, 0.84, and then 0.07, and then go to the top of column 3, 0.12, 0.09, and 0.79. So I'm just having a check here. Column 1, they add to 1. Column 2, they add to 1. And column 3, they add to 1. Okay, so that's good. Now I press enter, and look what happens. We now have the input is in blue and the output is in green, and notice that that T has now become bold and non-italicized. Now, the next matrix that I'm going to introduce is the initial state matrix. So our initial state matrix, the notation for the initial state matrix is S0. So I'm going to type S and then the number 0, and then control symbols template, and I'm going to assign S0 to be. Now, I can show you a quick way actually of setting up S0 without having to go through the menu. Is if you press control and then the normal open bracket button, that gives you, if you like, your 1 by 1 matrix, and then you do have a mysterious key down the bottom right hand corner of your keypad. I think it's called the carriage return key, and if you press that once and once again, notice that that adds some rows. So we now have a nice initial state matrix set up as a 3 by 1 or a column matrix. And so here I'm going to put in, these are numbers. So 1200, sorry, I didn't want 1200. I'll just go back and change that to 800, then 1200, and then 500, and then press enter. Okay, so we've got assigned our transition matrix T and our initial state matrix S0 or S0. Now, what we can do, often the question will be, you know, to find the numbers in each of the states after one transition. And what that would be is that would be saying, okay, let's take the transition matrix T and multiply it by S0 to give us a new state matrix S1. So we could set that up as a math box as well, or inside a math box. So what I can do is inside that math box, I'll type in S1 and control symbols template, and I can assign that to be equal to T times, now S0, I could type it in, but also be aware that anything that has been assigned we can call up by pressing the var key. Var stands for variable, so see how we've got T and S0. That's useful if what you've defined or assigned is like a word, or consists of a few characters. Just saves on typing. So we press enter, and so what this should give us is it should give us the numbers in each state after one transition. So S1, we've assigned it to be T times S0, and we press enter, and that's giving us the numbers after one transition. So let's say in one state we've got 848 roughly, 1101 and 551. We could also then set up another math box for the numbers after another transition. And so in this instance, it would be S2, and we could assign this, so this is control symbols template. We could assign that to be T multiplied by S1 and press enter. And that's giving us the approximate numbers after two transitions, right? So now we've got roughly 886 in one category, 1,025 in another category, and about 589 in the other category. Now, we could keep going on and on and on. There's also a lovely result that to be in the n+1th state, or S of n+1, that's equal to T times S of n. But we can also exploit powers of the transition matrix. For example, just here, if I was to write, let's say S2 again, and then assign that, which is control symbols template, and I assign that to be T squared times S0, I'm hoping that we get the same result for S2 and S2 again. Let's see what happens, and we do. Very nice. So we can exploit this, and we can come up with a rule for Sn, and we can say that Sn is equal to T to the power of n times S0. And we can also be quite clever, and we can insert an object called a slider, which we can use to change the value of n by clicking on it rather than always going into the math box and changing the value of n. So let's see what that looks like. I'm going to get to the outside of that math box, and I'm going to press backspace and get rid of that math box. And what I want to do now is I want to press menu, and then number 3 for insert, and number 5 for slider. And the slider settings dialog box now appears. So I'm dealing with powers now of the transition matrix. So let's call those powers, let's give it the letter n, or the variable n. So we'll type in n. We can start off with a value of 1. Minimum, let's say 0. Maximum 50. We can go up in ones. So you can press tab through all these fields. I like such sliders to be minimized. So if we press the click grab button, that checks the minimized feature, and everything else looks all right. So if we press enter, we now have a slider control which will change for us the value of n. Now if I press enter again, I can set up this general case in a new math box. Now I don't have a math box open, so this is where the shortcut is useful. So if I press Control M, that opens up a new math box, and I can type in SN, and I'm going to assign that, which is Control Symbols Template. Whoops, pardon me, press escape, sorry. So SN, I'm going to assign that to be T to the power of N. So times, I'm trying to use the calculator keypad rather than the computer keyboard, times S naught. Now, if we think about this, we've got n equals 1, and S naught, that's our initial state matrix, which contains numbers 800, 1200, and 500. So if I press enter now, that should correspond to S1 back up here. So S1, that's 848 roughly, 1101 roughly, 551 roughly, and it does correspond. 848 roughly, 1101 roughly, 551 roughly. And the beauty of this is that we can now, this slider and this math box are now linked. So we can change the value of n, and it will give us the state after a particular number of, or the numbers in a particular state after a number of particular transitions. That's the key. And what's also really useful is we can change the value of n really quickly and start to get a sense of what's going on in the steady state situation. Now, the study design or your syllabus says that you're expected to have some idea about an informal justification of the equilibrium state matrix. And really what you're looking at is you're looking at one state matrix to the next where there's hardly any change. And if you're able to show from one transition to the next that there's hardly any change, then you are informally justifying the fact that you've reached an equilibrium or a steady state. So you go inside, you make contact with the slider, and it's the right arrow that's going to increase the value of n. So by pressing, just try this on the handheld, either the click button or the enter button. There we go. So we can obtain the numbers after each transition very, very quickly. In fact, if I go into really introducing this, see how we're reaching each of those values is reaching a steady state. So in essence, what's happening is here we've got about 1,025 objects or people in the first state, the first category, about 777 in the second category, and about 698 in the third category, whatever those objects are. So for an informal justification, all you need to be able to show is the fact that going from one transition to the next, that there's hardly any change in each of those values. So this is a very powerful page. We can go back into the settings and we can change that value back to 1. Press enter. And the other thing you can do now is you've got it set up. So all you would need to do is for the 3x3 case, if there is one that you have to deal with in the exam, all you would need to do is go in and change the elements that are involved in transition matrix T and also initial state matrix X. So I'm not going to make many changes, but let's say if I make that 0.75 and then I make that 0.16, press enter, and then I can change this to say 600 and this to say 900 and this to say 300, and then press enter. You might have noticed there that the state matrix that represents the numbers in each category after the first transition, you might have noticed that they changed. Just be aware, just be really careful that for your transition matrix that each of your columns sums to 1.